first of all, um, when you get into a bond duration question, it could be math related. They could ask you, they could give you somebody who's going to retire in 20 years and they're going to put together a bond, or they're just going to buy a bond or put together a bond portfolio. We need to match the duration of that bond or that bond portfolio to the timeline of the client. We're not matching up the actual maturity date of the bond, right? So if somebody's going to retire in 20 years, she's going to dump a bunch of money into a bond portfolio that you're going to build for her. You're going to look at maturity dates of like 23 years down the road because the bond portfolio duration is going to be 20 years. And why is that? Well, your bond duration, well, if we look at like the Macaulay duration or the modified duration, one of the two, I might mix those two up, but regardless, first off, why, like, what is actually going on with bond duration? And you guys might know this from your coursework, but if I go and, so here's today, this is like right now, if I dish out $1,000, I'm not getting this back until, whatever, 5 years down the road. Okay, so I put 1,000 into this bond. I know it's coming back, so let's not worry about risk or anything like that. I'm definitely getting $1,000 back in 5 years. But you'll notice that if you did a calculation, that you'll find out that the bond duration is going to be something like 3.8 years or something. Okay, and on a time-weighted basis, I'm actually getting my money back before 5 years. Why is that? Because as soon as I dish out that $1,000, 6 months from now, I'm going to get, and let's just say it's paying 5% coupon. I'm going to get $50 here. In a year from now, I'm going to get another, sorry, this is $25. If it's paying 5%, I get $25 6 months in. I get another $25 6 months later or after 1 year. And here's year 2. End of year 2. And so on and so forth. And then I'm going to get this big lump sum of money, $1,000 right here. Okay, but why is it the average amount of time, mathematically speaking, I'm getting my money back in, let's just say 3.8 years. Why? Because just like, it's almost like gravity, where as far as like this $25, I actually start recouping this $1,000 6 months in, and I get another 25 of my $1,000 back. It's all about the return of the investment. All right, I start getting that back again, and I'm recouping my investment. Not all at once over here, unless it's a zero coupon bond. I'm starting to recoup it a little bit at a time. So just like little, I guess the little forces of gravity are pulling this $1,000 like that way. And that's why we get a duration of 3.8 years on a 5-year bond. Right now, when you get a bond duration question, they're going to ask you about, if the bond price is $950 and, it's paying an 8% rate of return, or the interest rate or the coupon is 8%. But, bond prices, they fluctuate. They go up and down, as do interest rates. If the interest rates fall to 7%, does this bond that's right now trading at $950 that has a coupon rate of 8%, is the bond price going to go up and down? Well, first off, we know if the bond rates, if we know interest rates go down, bond prices necessarily 100% of the time go up. So let's clear this out of the way, actually. And let me show you something as far as a shortcut. First of all, is a shortcut. If you're not familiar with the shortcut, if they're going to ask you a bond duration question as far as like how much is the bond price going to go up or down, you're going to have four answers to choose from. You might be able to eliminate maybe two of those answers right away if they're going to give you two positive and two negative answers, or if they're going to give you two answers where the bond price goes up or if the bond price goes down. Now, if they really want to be, mean about it, and they could be, if the interest rate in the question goes down, they'll just have four answers where the bond price goes up. And if they really, really want to get nasty about it, what they'll do is they'll give you four choices that look like, it should be A, let's just say A, B, C, and D. And they'll say, yeah, the bond price was $950. Interest rates went down. Bond prices went up. What's the new bond price? And they'll say, $971.33, $970.25, $972.46, and $970 and 62 cents, something. All right. Why would they jam all these together? Because they know that you might know that what this little shortcut is. Nonetheless, we're still going to use the shortcut because it's going to do two things for us. Number one, the shortcut could save us time. That's number one, if we're lucky enough. If they know that you know that the shortcut, they're going to make you do the calculation. In the calculation, the only problem with it is that you very likely are going to forget to put in a negative sign in there. I'll show you that in a second. So here's our shortcut. If the interest rate goes up, let's just pick up for a second, okay? If an interest rate goes up by 1%, this is, by the way, this is telling us by what degree the bond price is going to move. So if the interest rate goes up by 1%, then the bond price, of course, goes down by 1% times the years of duration. All right, so I'm going to make up an example here. Let's say that in the market right now, we have a bond, the current price is $950. Let's say that the coupon yield is like 8%. And let's say that let's say that's current. That could be misunderstood to mean current yield. So let's just say that the coupon, let me write that out for you. The coupon equals 8. And let's say that the current yield, I'll write it out. The current yield is 7.5%. Okay, so we've got a bond that's paying us $40 no matter what. It's a treasury, let's say. So all good there, in theory. So it's paying an 8% coupon, so we know we got semi-annual payments, 2 payments a year coming in at $40 a piece. But there's some market turmoil and investors are running for the hills and they're buying a bond. So and now that this price is starting to go up, but just a year or two ago, it was a risk on. They were selling bonds and putting in the stock market. So that's how we wound up to $950. Okay, so, that doesn't have much to do with the question other than, like I mentioned, I like to paint pictures in your mind's eye for you. So, okay, so we wind up here at $950. Now, market turmoil is returning and the bond price is being pushed up again, but we don't know what that is. The board wants to know where it is. Well, here's our original coupon. Now the current yield is at 7.5%, or winds up at being at 7.5%. And so what's the bond price? Well, it's going to look something, and let's just say that the duration, let's say that the duration is, 3.5 years on this thing. So if now what's happened to our interest rate? It's gone down by, let's make this a little easier, 7%. The interest rate has gone down by 1%. So the bond price will go up by 1% times the number of years of duration. So it should go up by about 3.5%, right? Interest rate has gone down 1%. So that means the bond price should go up by 1% times the number of years of duration. 1.035. So you take 1.035, multiply it by 950, and our bond price, since the yield has gone down, the current bond price should now be about $983.25. This is an approximation. Now, these are, I was just making those up as we went along, but this is about what it should be. So what you're going to expect to see on the exam, because again, they know that you might know that the shortcut, they're going to give you, answer A is this, but answer B is this, and answer C, maybe they just send the bond price down, I don't know, to 925.25, and answer D is 984.72. So if you use the shortcut, you might wind up answering this, but you've got to do the formula, because in the formula it actually might come out to be 983.82. So they're looking for an exact number on this one. Now, what is the formula? Let's try to fit this in here. Our formula is that the change in the bond price relative to the price of the bond is, this is where it gets a little bit messed up, is that this duration figure here on your formula sheet is always negative, because interest rates and bond prices move exactly opposite of each other. And you're going to have the change in the yield. In this case, this is a negative. We're going down by 1%. Okay, so this is where you guys forget also to put in this. That's what I was saying on your answers, the different answers they give you. What they'll also do is they'll give you a bond price that goes up. They'll give you bond prices that go down as well. Okay, and what they're hoping that you're doing is going through the exam too quickly. Like, oh, I remember duration, I'll just go through. Well, if you forget this negative sign, or if you remember this one, but you forget this one, you're going to get a number that moves down when it should be moving up, because these two negative, and like in this case, the two negatives are canceling. Okay, divided by 1 plus the original yield. The original yield was 8% here that we started with. And, just for, yeah.
Quick question. On the formula sheet, mine is not negative for the change in Y.
It is in this question. You're right. That's exactly right. And that's what I'm glad you asked that, because this is the change in the, let's get rid of that for a second. This is the change in yield, right? If the yield is moving down, this number has to be negative. If they give you a yield that's moving up, that means the bond price goes down. And what is this telling us? This is the change in the bond price. Look at these two negatives here. They're going to cancel out, and we're going to expect the bond price to go up to be around $983.25. Okay, is that any clearer? Did that answer? And it's okay, you can say it didn't, it doesn't make sense. I'll totally clarify it for you.
Yeah, I think, yeah, it's changing Y, right? So it's whatever, that's either going to be positive or negative. You use negative in our example because it's going down.
That's exactly right. But
Okay.
I'm so glad that you asked that, because you look at the formula sheet, it says change in the yield. Well, you have to know to put in a negative number if the yield is going down, because if we don't, you're going to wind up with a price that actually, the change of the price that actually goes down. All right.
Yeah, another question. So I didn't, and this is probably just simple math that I'm not following, but the 1% times the 3.5 years, why is that one? Oh, I think I may have not multiplied I was multiplying 1 times 3.5, not 0.01 times 3.5.
Yeah, it's just telling that one is always, that one right there is in there, because this shortcut is telling you, okay, this is how the shortcut works. Interest rates go down 1%, your bond price goes up 1% times the years of duration, and that gives us 3.5. Well, what it's saying is that, hey, increase the price of the bond by 3.5%. And the easiest way that you can do that is just that you take 1, which represents, maybe I should use red for this one, but you just use 1, which represents 1. It's taking 100% of the price and increasing it by 3.5%. You could also do like 950 times 0.035%, which is $33.25, and then just add it to 950 to get 983.25. But if you want a shortcut, you just take 950 times 1.035, and it gives you 983.25. Okay. Does that make sense?
Yes, thank you.
Okay. And let's mess around with these figures. This example, I completely made it up. I'm just curious, actually. This is what my shortcut tells me. Let's see what the formula gives us. And of course, you guys want to have 4 decimal points in. If that makes a difference in this one, it probably won't. But let's look at the change. What's our change? Let's go over to. Let me make some. Yeah, I'm gonna make some room. Let's look at our formula. So what is our formula? It's negative duration. Well, what's our, okay, so change in the bond price. Let's just do it this way. Change in our bond price relative to the price is a negative duration. So this is always negative. So negative 3.5. And let's close this off. What our yield is negative 0.01 divided by our initial yield, or excuse me, 1. And let's put that in blue. Let's say 1 plus our original yield that we were looking at. Doesn't necessarily have to be the coupon, but our initial yield. And let's see what we come up with a price, 0.01. Actually, that might be 0.001. Hold on 1 second. Let's just do the math on it. Times 3.5. That's a negative. Yeah, okay. So what does it come up with? We estimated the increase in the price to be what, 3.5, correct? And what does the formula tell us? We come up with, did you guys get 0.0324 based on our formula? If you did, you'll take 950 times 1.0324. And what you get is an exact price on this bond of $980.70, call it 79 cents. That's the exact. If interest rates on a bond that's yielding 8% drop to 7%, and the duration is 3.5%, we estimated it to be 983.25 just using the shortcut. Okay, but it actually comes out to be 980. Now I always say, or I always advise you guys, use the shortcut first, because maybe they might have a large enough difference in the answer choices where maybe this cycle around, they're not assuming that you know what the shortcut is. And if we can do this in like 15 or 20 seconds, that's great. Do it and move on. If all the answers are jammed together, okay, and the right answer winds up being 980 and 79 cents. Our estimate gave us this, but this is really the right answer right here. Okay, if the answers are too close to each other, then we revert back to the formula sheet, which might take us like another 45 seconds or so. And if I happen to forget that this is always negative, and if I happen to forget that, I forgot to put in a negative here, and so I wind up with a totally a negative answer, and the bond price goes in a direction, or it winds up being less than what I was anticipating with my shortcut, we are getting ahead of things by doing the shortcut first to show us that this thing actually should go up by about a certain amount.